Good morning, everyone. My name is Magar MH, Assistant Professor from MD Arts, BW Commerce College at Nashik. Today, I have started new chapter number 2, Problematic Soil and Soil Testing, lecture first. Started from introduction. The humid region soil are acidic in nature because of the formation of weak acid like carbonic acid, lactic acid, acetic acid, etc. These acids replace basic cations like calcium 2 plus, magnesium 2 plus, K plus to cation exchange sites with H plus and Al3 plus. These replaced cations are leached into deep soil by water. This extent of the salt present in soil changes its nature. Excessive concentration of soluble salts or exchangeable sodium or both make the soil saline or alkaline. Excess of salt in the soil is toxic to plants. Some of the problematic soil are acidic, saline, alkaline, calcareous, saline, alkali, and non-saline alkali. Next is acid soil. In acid soil, formation of acid soil. Acid soil are formed under the natural conditions as well as artificially by the continuous use of certain fertilizers. Soils developed in humid region are mostly acidic. Under these conditions, the alkali and alkaline earth bases that are liberated during weathering are leached out, leaving the soil deficient in bases. When all the soluble bases are lost, the H plus ions of carbonic and organic acid replace the basic cation of the colloidal complex. As the soil gets gradually depleted of its exchangeable bases through constant leaching, it gets desaturated and becomes increasingly acidic. Acid soil can also be produced through the accumulation of the organic residue. The decomposition of organic matter in the absence of oxygen gives rise to a product called pitch, which is acidic in reaction, and it is due to the accumulation of humic acid. Acid soil are also produced by continuous use of biologically acid fertilizers on the soil that is poor in lime. When nitrogenous fertilizers like are added to the soil, the gets vitrified and nitric acid is liberated, which reacts with the calcium and other bases to form nitrates. Nitrates are very soluble, so they are either absorbed by crop or lost in the drainage. At the same time, a part of NH4 plus. NH4 plus means ammonia. 4 plus is the oxidation of NH. Ions are absorbed by the soil colloidal material by replacing calcium. Anions form sulfuric and hydrochloric acid which further decreases the soil solution and colloidal complex of their phases. New point is the effect of soil acidic of the soil. The soil acidity is also increased by the use of material like sulfur, molasses, etc., which liberates acids during the decomposition. The increases in acidity decreases the soil production. The soils that are predominant in the alumina silicate clays are made of alumina and silica layers. In acid soils, an equilibrium is maintained between the H plus ion and Al3 plus ion. H plus means hydrogen, Al3 means Al means aluminum. P plus is oxidation state of aluminum. The reaction is Al3 plus in presence of water molecule, that means H2O. It gives AlOH 2 plus. 2 plus is oxidation state of this complex, and H plus. Next, AlOH 2 plus in presence of H2O, it gives AlOH plus 2. That means AlOH molecule is 2 and H plus is liberated. Next, AlOH plus 2 in presence of or in addition of H2O, it gives AlOH 3 plus H plus. In such a soil, poor growth of crop takes place. Slightly acidic soil are quite suitable for growing crops without any treatment, but those are strongly or even moderately acidic do not allow the normal growth of plants. So acidity has to be neutralized before the crops are grown. The lack of exchangeable bases in the main causes of unproductiveness, which can be restored by adding lime, dolomite, etc. The reaction is calcium O, calcium oxide means CaO plus in presence of H2O molecule, it gives CaOH2. The CaOH2 plus 2 mole of CO2, it gives CaHCO3 2. As the concentration of CO2 in the soil is quite high, all these compounds are converted into soluble bicarbonate, which then react with the soil colloids. H2 clay plus CaHCO3 2, it gives Ca clay plus 2 mole of H2CO3. The carbonic acid further reacts with lime and repeats itself and turn colloidal clay into the Ca clay, which increases the pH of the soil. The carbonic acid further reacts with the lime and repeats itself and colloids clay into Ca clay, which increases the pH of the soil. This reaction is reversible in nature, therefore additional quantities of lime are added from time to time to maintain the pH of the soil. Gypsum and CaCl2 cannot be used for providing acid soil because they are neutral salt with no alkaline effects. Their addition makes the soil more acidic. Next point is declamination of acidic soil. In this point, the lime requirements definition. The quantity of the lime required to be added for soil is known as its lime requirement. It's denoted by Lr. The initial the pH. It depends on the base unsaturated, and lime required also depends on the type of crops to be grown. The lime requirement varies universally as pH and buffer capacity. Procedure for determining lime requirement. Known weight of the soil is mixed with varying quantities of standard CaOH2 or BaOH2 solution in a number of flasks and allowed to settle down. That means these two compounds are prepared, these solutions are used and they are allowed to settle down. The pH is determined electrometrically. The titration curves are drawn from the obtained data and the quantity of lime needed to produce any particular pH is calculated from the curve. Usually the pH is 6.5 or 7 is taken to represent the desired pH for most crops. The quantity obtained is multiplied by the timing factor gives the actual time requirement. Effects of lime on acid. First, lime improves chemical and biological properties of acid soil without affecting its physical conditions. It encourages the decomposition of organic matter, producing excess of organic colloids. Next, the calcium humus produced during the reaction acts as consenting agents in binding the soil particles. It increases the availability of the almost all the plant nutrients like Na means nitrogen, potassium, calcium, magnesium, boron, zinc, copper, and reduce the toxicity caused by the soluble iron, Al, and Na. It encourages the microbiological activity of the soil by raising the pH. It stimulates the rapid decomposition of added organic matter, resulting in increased microbial activity, which increases the availability of nitrogen, potassium, phosphorus. Overliming of the soil is toxic for crops. It is the toxic especially in case of sandy and organic matter deficient soils. It reduces the availability of major and minor essential nutrients like iron, Mn, P, calcium, zinc, P, that means potassium, P, sorry, uh, phosphorus, potassium, etc. It is also it interference with absorption of certain elements like potassium, phosphorus, boron, etc. by plant, thus hindering their utilization. It also affects the very rapid decomposition of organic matter in the soil of arid and semi-arid regions. Therefore, in order to make the acid soil fertile, a moderate quantity of lime should be added from time to time rather than to make a heavy application at a time. Thank you.